All right, hello. We're continuing looking at section 3.3 in the Lock 5 textbook, Statistics, Unlocking the Power of Data. So we're going to look at Atlanta commutes. So we want to know, say, what is the mean commute time for workers in the metropolitan Atlanta area? So we have a bunch of data from American Housing Survey from 2004. So we've got a random sample of 500 commuters. So we have the commute times of 500 commutes. This is one sample. So we've got most around the 20, 30, 40 minute mark. And then there's a couple that are traveling quite a longer distance, or this longer time. So we've got a sample of 500. The average of the sample is 29 minutes. And the standard deviation of the sample is 20.72 minutes. So if we want to know, well, where might the true mean be, the true average commute time for metropolitan Atlanta commuters with one sample, we could bootstrap. We could bootstrap to find out. So bootstrapping would be done in StatKey. We have 1,000 samples right here. We have 1,000 samples, and here's the original sample. And then each one of these 1,000 dots corresponds with one bootstrap sample. So there's 1,000 samples done on here. If we want to compute a 95% confidence interval for the average commute time of Atlantans, which would it be of these three options? Or maybe you have no idea. Or the answer for this is B. So we're going to take the sample statistic, which is the 29.11 from the original sample, add or subtract 2 times the standard error, and the standard error is going to be the standard deviation of the bootstrap sampling distribution, the 0.915. So 2 times that, add or subtract 29.11, gets you to 27.3 to 30.9. Another example, what percentage of Americans believe in global warming? Survey was done in 2010 of 2,251 randomly selected individuals, and 1,328 answered yes, there is solid evidence of global warming. Let's give and interpret a 95% confidence interval for the proportion of Americans who believe there is solid evidence of global warming. So we need to go to StatKey, and we'll go over some example of this both in class, and I'll make separate videos. But for right now, if you go to StatKey and looking at bootstrap for one categorical variable, looking at confidence intervals, and there's 3,000 samples. So we got the original sample right here, 1,328 out of 251, said that there was evidence for global warming. And from this original sample, 3,000 bootstrap samples were generated. All right, so this is your p-hat, your proportion, and the standard deviation. This is the standard error, 0.01. So to get the 95% confidence interval, we're going to take 2 times this standard error, 0.01, add and subtract that to the sample statistic, 0.59, to get 0.57 to 0.61. So we're 95% sure that the true percentage of all Americans that believe there's solid evidence of global warming is somewhere between 57 and 61%. All right, so let's take that same data and look at, is there evidence, or does belief in global warming differ by political party? So same question, is there solid evidence of global warming? And that sample proportion answering yes was 97% among Democrats and 38% among Republicans in 2010. So we're not going to give the exact numbers, but we're going to assume that we have 1,000 for each group. So let's give a 95% confidence interval for the difference in proportions. So here we'd be looking at bootstrap for 2 categorical variables. And if we entered in the proportions, the group 1 was 790 out of 1,000 to get the 79%. Group 1 is Democrats. Group 2 Republicans, 380 out of 1,000 to get 38. So the difference between these groups is 41%, 79 minus 38, 41%. And here in this graphic, we've got 1,000 bootstrap samples. So we've got 1,000 samples created from these two different samples, or samples of differences. So each of these is a bootstrap sample, and they compute the difference. And the most important part here is the standard error. The standard deviation of the sampling distribution is 0.02. So we're going to take the sample statistic. The difference is 41%, 0.41, and the standard error is 0.02. So we're going to take the point estimate, the 0.41, plus or minus 2 times the standard error, 0.02, to get the range interval of 37 to 45%. And we'd say we're 95% sure that the difference in the proportion of Democrats and Republicans who believe in global warming is between 37 and 45%. So based on the data we just analyzed, at least from the 2010 survey, can we conclude with 95% certainty that the proportion of people believing in global warming differs by political party? Definitely yes, because that confidence interval doesn't come really close to zero. If your confidence interval for a difference of means or a difference of proportions does contain zero, say it goes from minus 0.2 to minus 0.3, that would mean that there is evidence that there's no difference between the two groups. But since 37 is fairly far away from zero, zero does not contain, or the confidence interval does not contain zero, then we could say there does seem to be a difference with 95% confidence. All right, as a summary, to generate a bootstrap distribution, we generate bootstrap samples by sampling with replacement from the original sample, and we use the same sample size. We're going to compute the statistic of interest, a bootstrap statistic for each of the bootstrap samples. And we're going to collect all these statistics for many bootstrap samples to form a bootstrap distribution. So keep in mind the second two parts generally are going to be done with a stat key with computer simulation. And if the bootstrap distribution is symmetric and bell-shaped, everything we've seen on the slides was true. And generally, if your sample size is big enough, this is going to be true. But you always want to check. Compute a couple thousand bootstrap distributions on stat key and make sure you have a symmetric and bell-shaped distribution. Then 95% confidence interval can be estimated by the formula. Take your sample statistic, plus or minus 2 times the standard error, and that standard error is estimated as the standard deviation of the bootstrap distribution.